So number 39, we have a 150 kilogram merry-go-round in the shape of a uniform solid horizontal disc of radius 1.5 meters is set in motion by wrapping a rope around its rim and pulling on the rope. What constant force must be exerted on the rope to bring the merry-go-round from rest to an angular speed of 0.5 revolutions per second in 2 seconds? Well, immediately you should think, all right, I'm going to be using Newton's second law, the rotational equivalent of it, torque equals I alpha. But we got a problem. The initial velocity of this thing is expressed in revolutions per second, not radians per second, what we'd rather prefer. But we can do a quick conversion. 0.5 revolutions per second multiplying by the 2 pi radians in each revolution. You very quickly realize, it's going to be pi radians per second. That's our omega. But to solve this, we need to actually have alpha, the angular acceleration. Well, again, remember, alpha is just defined as the change in omega over the change in time. In this case, it goes from 0 up to pi radians per second, what we just found, in 2 seconds. And so if you divide that out, it gives us 0.5 pi radians per second squared. That's our angular acceleration. So we've got that. And so now we can actually start solving this. The torque is going to be force times radius times the sine of the angle. And it may not be obvious yet, but whenever you pull a rope off of something, it always comes off perpendicular to the radius. So the angle here is simply going to be 90 degrees. And the radius here is simply going to be the radius of our disk. The 1/2 mr squared comes from the table of rotational inertias. This is for a disk or a cylinder. And then we can just plug in our numbers. So in this case, we don't know the force. We know the radius of this thing is 1.5 meters. Its mass is 150. And plugging in alpha from over here, which is 0.5 pi radians per second squared, we can solve this for force. And if you do so, you'll discover the force required is about 177 newtons. I hope that makes sense.